Okay, three things to show here. This is the Wi-Fi modem solution. The first of three things is really to talk about attributes of this particular solution. You know, how fast is it? How do you connect it? And all the rest of that. I touched upon this briefly in the prior video, which was a CBBS kind of focused video. Talked a little bit about the history of BBSs and communication. Here I'm talking about some pretty detailed specifics about the F256 and its serial port and how to configure it. Setting baud rate, stop bits, parity, and all this other business used to be considered modern, right? This is modern technology, 40 years ago, 50 years ago, 40 years ago. But here today, we're talking about it specific to the Foenix. And if you look on the screen, you'll see a bunch of notes with the basic program that I talked about previously. What I want to do is give a little bit of a deep dive into these settings, and I'll be brief. This pertains to anything you're connecting to this machine to either the serial port or the feather footprint. Now, in this C256 Jr., there's a, you can't really see it. I'll see if I can tilt this. But under there is the feather footprint. On an F256 Jr., it's right here. So right about here. So the feather footprint, of course, is the same kind of through path as the serial. And there's a set of jumpers to configure whether you're going out of the DB9 or out of the feather footprint. This exists on the K also. But I guess what I'm here to say is that there's a way to use this for anything, anything you want. You can communicate with a Raspberry Pi, with an Arduino board, with an old school modem, as I showed previously, with MIDI, with Featherboard, etc. So you do it through a bunch of registers, and those are located in the I/O bank of the C1000 range, and that's C1000 through, I guess, DFFF. And the addresses are numbered based on where they're inserted from a Texas Instruments 16750 UART perspective. The Tiny Vicky FPGA has an instance of this Texas Instruments chip in there. Of course, in the old days, you had to actually buy the chip from TI, solder it on the board, and you would use a series of logic gates to map that into your memory address space. But here it's done through the magic of Tiny Vicky and FPGA, so there's a block that represents the 16750 UART chip. But for us, it just really means there's 8 addresses, and you use them as follows. So I have mapped out on the screen here. First is the magic address, which is D633. This has a bit called DLAB, which really just signifies whether or not some of the register will be used to dictate the speed of the UART versus other settings of the UART. And when there's a bit in this 7th bit of D633, so if this was a 1 here, this 1 bit was set, then I wouldn't be necessarily talking about, parity, stop bits, and all the rest of it. Instead, I'd be talking about how to set the speed. And these are really 2 bytes in here, or 3 bytes, I should say. D630, 631, and 632 pertain to the speed that the UART's configured as. I don't believe there is a default, but there are certainly some popular, bits per second ranges, and I've detailed those here. This comes straight out of the Foenix F256 manual that Peter put together, although this is an abbreviated table. So in the manual, you'll see things like 300 baud, 600 baud, 1200, 1800, 2400. It goes up in increments like that. It tops out at 115K baud. You'll notice that there are many missing here, as I just mentioned. One of the ones that is missing is 31250, 31K, 0.250, which is MIDI. And if you're watching in my prior videos, you'll see that I have a kind of DIY MIDI interface connected up to my system, and I use this very same technique to get the speed and the baud rate working correctly. The math, you can work it out in a spreadsheet, but the math essentially works out to a high byte of 0 and a low byte of 50. So poking those into the appropriate registers, being D630 up here and D631, pertain to the low byte and the high byte, as you can see here. There's a low byte, and here's the high byte. So that's 630 and 631. There's another, divisor called the pre-scalar division byte, and I'm not using that. So I poke a 0 into that, and you'll notice up here on the first line of the program, line 10, I've got 128 poked into D633 to say turn DLAB on. Then I'm poking 31 into D630, 5 into D631, and a 0 into D632. So let's see. I think that's really about all I'm going to cover here. By the way, the 5 and the 3031 pertain to 1200 baud. I should have mentioned that previously, but you'll see I have no key click on this. No key click, no repeat on this keyboard. So I'm making a bit of a racket here. Hopefully it's not too distracting. But here we are, 1200 baud line. The divisor value is 1311, which if you do the math, it's 5 times 256 plus 31. So that's just a little bit of a detail. It's not very useful unless you feel like changing the baud rate and trying different values. Then it's extremely useful. The manual is a bit misleading. I'll say it's technically accurate, but there's one point about running this chip, the 16750, in what's called polling mode when you want a 64-byte FIFO, which is what I want here for basic. I'm not using interrupts. I want it to be simple. And when you run it in a certain manner, there's something which is like a 56 byte out of 64 bytes trigger that will, it's complicated. I won't go into it now. But all I'm saying is there's a correction to the manual. I'll put it into the description. So have a look at the description. It doesn't really affect this here. I have the correct values poked in, but there's more to the spec sheet than is represented in the Foenix manual. So I guess that's number one. Number two, I'm going to talk briefly about attributes. I'll put this up on the screen. This is a 3-wire serial port implementation, as I mentioned previously. The hardware platform is, of course, an embedded controller. It has an ESP8226 built into it. This modem does. There is no real assembly required, right? If you have a K, you just plug it onto the serial port in the back, which looks very much like this. If you have a Junior, you'll need to establish this wiring. From a power perspective, the modem needs a USB mini type B. From a software perspective, well, you need some kind of software to run to talk out the serial port and to receive data from it. And that's all up to you, really. So you can use this 5-line program. You can use something like F-Term, which Micah Bly has been is putting together, which is a full-featured terminal with ANSI and color screen support. The communication standard is somewhat interesting in that data is sent just byte for byte to, in this case, the serial port. There's no packets, there's no checksums, there's no handshaking. It just simply sends the data at the proper baud rate from the UART out this serial cable. So it's just really a streaming of data. Once the modem receives it, it packages things up into telnet packets and sends it across port 23 or other ports, depending upon what you're connecting to. And the BBS list has a whole list of ports. As you'll see, some of them are clever things like port number 6502. The CBBS example I gave in the last video was to port 8800, which was kind of like a throwback to or a tip of the hat to the Altair 8800. Altair? Maybe it was the MSI 8800, whatever that model was. One's a clone of the other. Other thing to say about this is that there's really no other services available for it. There's, it's very low budget. It cost around $35 for this, and I'll put a link on where to buy it. I had a link in the prior video as well. And then finally, in summary, this solution is, I'll say it's saying on text, you can see it in front of you. It's fun for cruising around. There's hundreds of these BBSs still online. And you can use this for terminal style software file transfers, albeit at lower speeds. Meaning, if you have a piece of terminal software that can accept either an X modem, Y modem, punter protocol, you can certainly file transfer or transfer files from the host to your system being written to your Foenix SD card. I should mention one other thing about baud rate, and that's that this Wi-Fi modem, which I have it right here, actually, I'll pull it off, comes, I'm going to take my adapter off of here. It comes, I won't say strapped to 1200 baud, but this is made for vintage computers. So they typically run as high as 1200 baud for a 1 megahertz chip, something that ran back in, 1978, 79, 80, 81, 82. But you can run this at faster speeds. So you can configure your machine there at 2400 baud, and you can type AT command set commands by configuring registers. It's probably like ATS something to make this run at 2400, 9600 baud. Of course, you need the software to keep up with it. We're running a 6.29 megahertz clock here. I'm running a SuperBASIC program that keeps up quite easily with 1200 baud. In the old days on a 1 megahertz 6502, you could not dream of pushing 1200 baud with it. But, you know, there are machine language programs running on this platform pushing, you know, 230 something K baud. And I believe that Boise Pete and his drive-wire interface speaks that out the serial port from an FNX 6809 CPU. Of course, the CPU is not really that important because it still runs at 6.29 megahertz. But, you know, just out of the box, this comes at 1200. You can probably push higher baud rates. So that's all for number one. We're going to reconfigure the bench here, and we'll come back and talk about a feather footprint. And we'll move on from there. Okay, so the second of the three solutions here is based on the feather board, and I'll be using an F256K to demonstrate this one. And then here's, of course, my Wi-Fi modem from the first solution. So to install it, it's an internal solution as opposed to this one that plugs onto the serial port, as opposed to the, where is it, if we get to it, the Meatloaf solution, which plugs into the IEC port. This is internal only. So let me yank this top off. There's 4 screws on the bottom of the F256K. This ribbon cable you need to be a bit careful about. And, well, there it is. So I've got, is this B0B? This is B0B. That's the version number of this system board. I did a video 6 months ago or more about the differences between the prototype, the early version, and this version, I believe. And I don't think there's been another revision. I'll just point out 2 or 3 things, then we'll talk specifically about the feather board and what it's all about. First thing to mention is that this Altera Cyclone, this is a Cyclone 4, is similar to the Cyclone that are on Junior boards. But this system has an additional FPGA. It's a Trion FPGA that is used for, I think it's used for, well, it's definitely used for the 2 Gideon SID instances in there. And there's some other functionality, not necessarily required on the Junior. Otherwise, it's essentially the same system. There's one difference from an audio perspective, and that's that the K has an OPL, a Yamaha OPL sound device. But otherwise, it's essentially the same system. So I wanted to at least mention that for those not familiar with the difference between the K and the Junior. But look for that video if you're interested in the difference between generations of Ks and the difference between the Junior and the K. So here's the feather. Mine is not installed. I just kind of pushed it down there. It's not soldered in. But in order to solder it in, you'll need to, of course, remove the four hex screws from the bottom of this, separate the cover, pull all the hex screws off of here, turn the board over, solder this in, push some code into it, and then configure it. There are 2 videos, one by a guy named Michael or Michel from, I think it's from Quebec, Canada. He goes by the name MUON and has 2 YouTube channels, one called, oh, here it is actually, 1-Bit. He has 1-Bit Fever Dream and then Any Bit Fever Dream, I believe. And he did a rather extensive installation video on how to install this into your system, things to watch out for, the steps to take. Separately, Peter from, he did a lot of work on the Foenix platforms across the year. He goes by the name PJW on the Discord, and he has a YouTube channel called Tail Recursive, and he also did a video. Now, Peter's video is more bullet point format, a lot of technical detail. He doesn't really show any of the assembly or the steps required to solder this in or any of the tips and pointers, but he spends quite a bit of time on the technology. Michelle, on the other hand, does a lot of kind of hands-on soldering, time fast forward as he does soldering to put this thing in place. I recommend, if you're interested, watching both of those. I'm not going to talk about those details here. But yeah, to tell you about it, at least, it sits here. It's a 28-pin Feather Huzzah. It's based on the ESP8226. It looks very similar, at least this portion of the board, to the Wi-Fi solution, because it's, essentially the same module, right, an 8266 with the antenna built in. This has, I believe, I'm not even sure if it's the same exact configuration in terms of the clock speed and the amount of flash on. It's not really that important. But there are only, out of the 28 pins, there's only 4 pins required to be connected. And Stephanie's confirmed that none of the other pins are connecting to anything. So you can solder them in or you can not solder them in. I would. But I would also suggest using a socket. But the pins that are required are transmit down here, TX, receive, RX, a 3.3 volt here, and one of the grounds. I'm not sure if there's there. The ground right next to 3.3 volts. It's actually on the other side of a not connected pin. There's also a reset button here, which is the same as pushing in the onboard reset, which may be handy if you want to do some troubleshooting. I'm not sure where you would route that wire or install a switch. There's probably a good place right here on top of the USB if you feel like drilling through this little panel here. So that's in a nutshell what the hardware is all about. I'll read through the list of attributes real quick as I did prior. So I mentioned already soldering PCB 28-pin footprint, Expressive ESP8226 80 megahertz 4 mega flash, draws 3.3 volts from pin 2. You really need kind of intermediate through-hole soldering skills to install this. It's not too harrowing, but it is dot 0.100 dot pitch, and if you bridge pins, bad things can happen. Again, watch the 2 videos I mentioned, or at least the MUON's video, to get some tips there. From a software perspective, there's you really have to write your own software. Although microkernel comes with TCP/IP communications embedded, and there are a number of callbacks or events, I should say, that let you talk directly to the internet. There are communication standards, which is essentially everything IP, right? TCP and UDP services are offered. Microkernel talks SLIP, Serial Line Internet Protocol, I think it's called, but it's essentially it's IP over serial between this chip and this board. So it's essentially talking serial straight out, but the microkernel packages up those into packets, as opposed to this solution, which simply just sends the bytes out in kind of a stream. The other thing about microkernel is there are events for waiting for incoming packets coming along. You can write any piece of software you want. You can download open source, network news transport protocol type clients, and compile them or assemble them using just standard system calls, which map fairly well to what Gadget presents in microkernel, and you can get that software running inside of your Foenix. But there are at least 2 pieces of software available. One is wget, which is kind of web-get. It's essentially there's get and post properties of the HTTP protocol, and wget will retrieve a file over the wire, so to speak, over the air, and write it to your local disk. The second thing that's available is something called the Mush client, which Gadget also wrote. Now, she wrote both of these by taking, I guess, understanding the protocol and writing her own assembly language from scratch to implement those. And those are both featured in each of the 2 videos that I'll link again in the description to this video. Getting back on track here, throughput of this device is kind of pinned at 115-200 bits per second, which is extremely fast compared to 1200, the default 1200 bits per second on this Wi-Fi modem. So you're talking about, I don't know the math, but maybe something like 96 times faster. Other services I mentioned already. The cost, this is about $18.99, I believe, from Adafruit, and you can buy this with the stacking headers, where you can get just standard headers if you like. You don't need this to stack something on top of it. In fact, it's rather useless to do so. This came this way because I was originally going to plug it into a board and do some work with a MIDI hat that sat on top of this, but I went in a completely different direction if you've seen any of my MIDI videos. But yeah, for 20 bucks, you can get your hands on this. Just use standard headers, and again, you only need to solder in the 4 pins. You don't need to solder all of them, but I would also recommend using kind of a header row here and here. I wouldn't solder this straight to the board, but you can if you're feeling sassy and you want to just go for it, make it a permanent part of your rig here. The other thing I should mention is that, of course, you've got the 2 jumpers in the K. This is the first time I'm showing those. But in the bottom position, all of the serial communication will exit via the DB9 port on the back, which is right here. In the up position, looking at it from this perspective, all of the serial I/O, well, one is for input, one is for output, but the serial I/O will traverse through the feather footprint, come through the pins here. There's a third option for this, footprint, and that's, at least in my case, to use it for MIDI. And I've used it to attach a Dream chip to the system. And of course, if you solder this in place, you're no longer able to do that because you're now tying up and directly connecting the send and receive connections to this device. In which case, I would, if I was going to have several juniors, but I would probably put another switch here, kind of a triple throw, double pole switch, which in one position would move these. In another position, it would go to the Feather board. In a third position, it would kind of break out of here and go to a Dream chip for this system. But that's just me. What else to say? I'll give you a walk through some of the microkernel calls in just a moment. I wanted to mention also that the next generation of F256 platforms, namely the K2 and the Junior, does not have a Feather footprint. What it does have is an onboard WIZnet chip, which has an antenna, I think embedded. There was some chatter about possibly having a wired antenna like this one, a wired antenna that would kind of screw onto the back of the device. Although, of course, it's a bit different on the Junior. That was really the question. On the K2, it comes with this, where it can plug onto the back of it. But it's a little bit different of a device. It's more like this in terms of the IOs going straight to the chip. But of course, it's seamless because it's integrated, fully integrated. I don't know enough about that platform yet to know how you would program TCP/IP communications without microkernel running. So at least in the extended mode, as they call it, where you have a 65816 processor, a flat memory map, no microkernel, you would use an AT command set on the WIZnet chip to talk to it and configure it. I looked over the manual for WIZnet. It doesn't seem particularly comprehensive or friendly. There's a whole series of kind of AT commands, and the manual is not very well written. I'm talking specifically about the WIZnet manual. I'll put a link to that just so you can get a hang of it. So that's I think I've covered everything I wanted to for the Feather solution. The summary here, and I'll read it just straight off of the screen here, is it's the most full-featured if you're interested in either developing your own code for peer-to-peer, custom, or for standard internet protocol applications. And I give the example of taking a network news reader and porting it to the system. I don't know how many NNTP servers are out there these days, but it was once all the rave. Okay, quick introduction to the third method to get your F256 online, and that's via or with help of Meatloaf and the Meatloaf project. If you're not aware of it, the Meatloaf project was started, I'm going to say 3 years ago, maybe more, by Jaime Johnston, or James, I think is his real name, James Johnston. Goes by the name of Jaime Idolpx on Discord and elsewhere. This is what it looks like when it's attached. That light flashing there is always flashing. It's based on an Expressif D32 Pro, which is packaged by a company called Lolin, Lolin. I want to just draw a quick similarity between the way that the Feather board, or what the Feather board and where's my Wi-Fi modem, have in common. In the last segment, you saw me do this and hold these two 8266 circuits side by side. What I didn't mention is that this is made by Expressif, of course. Others package it in certain ways and sell them. Of course, this one's open source. The modem's open source. You can buy this yourself. You'll notice there's an IC on here. That's a Max 32 chip because it needs to talk serial line levels. So that's why they use that as kind of a major feature. Otherwise, it's, kind of a closed system. You can, there's a couple pins there. I'm not sure what they're for. But other than that, you can put your own code in it and use the hardware for something if you can dream up an application. It is open source. This, however, is definitely open source. You can use things like CircuitPython on it if you like. Plug it into a board, give it 3.3 volts in ground, and go crazy with the GPIO pins and put all kinds of code in there and have it drive servos and do other things. But these are both based on the 8266. Meatloaf, on the other hand, is based on the D32, which is probably twice as fast and has quite a bit more flash memory on it. So it's a little bit more expensive. But you'll see as well, it's got some different chips and you can do you can probably do, I'm not sure of the standards, to be honest, but many of these have even ways to attach a screen directly to it, a small OLED or backlit screen. So Jaime created kind of the platform, the hardware platform. He went through a couple different designs. He writes the code, the embedded code on here. He's got a server out on the internet, and he's got a flash-based application, or an application that flashes, the code onto here. So it's really low touch, pretty simple to put together, and I would say low risk, because really what you're doing is you're soldering 6 wires to this board. And I don't mean this board, I mean this board. I'm gonna, really quick, if I have a scissor, I'll open this up just to show you what you get when you buy it. And I bought these from probably AliExpress, you know, China. You get headers, and you get the Lowland product. So the thing to point out is that there's a, you know, kind of a recipe put together by a guy named Deadline, a really great video I'll link to, where he kind of walks through how to build your own. And all he's doing is soldering the 6 wires that come out of an IEC connection into 6 points on here. And you could literally have those wires just flopping along and put this on the side. Again, powered by USB here, right? This one's a micro. There's a reset button on here. There's a slot for a mini SD or micro SD card. And you can get up and online. Flashing it is simple. You connect a USB connector from this port to your PC or Mac. I have a Mac. And then you go to Jaime's site. I'll put the link below. And you click a button that, you know, senses it and flashes it. I need to point out that in Deadline's video, it was made quite a while ago before Jaime had the Chrome-based or the web-based flasher running. And at the time, it required doing something like installing a plugin into VS Code. So you have to plug a plug into there to kind of talk Serial. You have to edit some code, make some changes. It was a little bit of a more of a heavy lift to program the thing. Now it's very simple. You plug it in, you go to a certain URL, you click 2 or 3 buttons, and it says go, and you see the you know, the progress bar go across, and you're done. So that's what that's all about. I want to show you kind of a more finished version of this. I posted this on Discord, both on the Meatloaf Discord and on the Foenix Discord a while ago. And this is essentially this, except I've went further and wired it with kind of a parallel attachment or daisy chain attachment to this other IEC connector, so I could plug in something like a 1581 drive if I wanted to. I put a reset button in here because it was a little bit too cumbersome sticking a toothpick into that hole, which was my original design. And I have a very short length of wiring on here. So, but otherwise, it's the same exact thing. So here, I solder it to a board and wire to the board to those pinpoints. And here I don't. This is Velcro to the top of my machine. I'm all set up now. I'm going to demonstrate for you several ways to go about using it. Before I get started, or before I jump into that, I'm going to say that this is uses largely the Commodore load interface to navigate around the internet, to navigate from the built-in flash here to the built-in SD card, which we don't necessarily need because we have it built into our systems, to various points on the internet. And what you're going to end up seeing is me navigating first to here, easily going to the Meatloaf share, and then there's a redirect that goes to the Meatloaf share to a Foenix share. When I say share, I mean it's a point on the internet. It's a web server serving out binaries and basic programs. And I've got that running now. It's partially integrated with the App Store. But the beauty of this is, again, no soldering on your Foenix machine at all, right? To the extent that you feel confident that you've soldered these 6 wires in the correct location, you just plug it into your IC connector, get online, no software to add, and you just basically type load commands. So let's jump into the demo and be prepared to be impressed. Okay, demo time. I'm at the F256 Jr. basic prompt, or the super basic prompt. I've got my Meatloaf device connected to the IEC port on this F256 Jr. This is just a standard Junior. I think it's a Rev B0A. B0A, yes. B0B is the tan colored one. But despite the fact that I have 2 SID chips, a 256K expansion, some wired headers and things like that, it's just a standard Junior. So the point is, take any Junior or K, plug this into your IEC port, flash it, configure it to use your Wi-Fi, and you'll be online. How do you access it? I know you're wondering that. Simply from DOS or from the super basic prompt, if you say DIR, you'll get the default SD card. And you'll see this is about as organized as my MacBook desktop. Thousands of files, no structure, it's just a mess. So this is the SD card again. Let me clear the screen and now change to this device. To change to it, you simply say drive 1. What that'll do is it'll change to, you don't get any kind of feedback. What that does is it changes to now tell SuperBASIC, and in some cases tell the kernel, to use IEC bus device 8. And that's what Commodore used for their drive nomenclature. Device 8, 9, 10, and 11. Here we're talking about drive 1, 2, 3, and 4. To get back to drive 0, or the SD card, you just say drive 0. But now that I'm on drive 1, I'm going to say dir to see what's here. And you'll see a bunch of files and something a little bit different than you're used to. And that's at the top here. The disk header says Meatloaf CBM. Now this is coming out of the flash built into this Meatloaf device. And you'll see a bunch of files here that all seem to be similarly named with an FB. That stands for file browser. None of these are of much use to a Foenix machine, but these are indeed file browsers. I think they're written in machine language for the 128, the 16, a VIC-20 with 3K with 8K, etc., 64 PET, etc. There's a wedge as well. And then there's this thing called meatloaf.url, which is a 1-block file, which means it's less than 254 bytes. What I'm going to do now is I'm going to load, just normal basic load command, meatloaf, it is case sensitive, .url. Press enter. After a very slight delay, it says file not found. I happen to know that it did find the file. And now if I say dir, you'll notice something a bit different. After a slight pause, I have a different directory now. And this is a directory on the internet. Actually, I'm looking at the Meatloaf archive. And from there, the URL is c64.meatloaf.cc. And then you'll see a bunch of files and or directories. The directories are hard to discern, except you'll just need to know anything below the line that 0 bytes is a directory. Anything below the line that has a blocks, number of blocks is indeed a file. You'll see some of the same files repeated here. You'll also see down here there's a file called Foenix, or a 0 block file called Foenix, which, as I said, is now a directory. So from here I can change to this by typing the load command. Now again, the Foenix machine, especially in BASIC, does not have any how do you say it? Well, easy to navigate, hard to say. I can't say the word navigable, well, whatever it is. Way to navigate subdirectories. But within Meatloaf, loading the next URL, you probably get the idea now, will descend into this file, this directory, which is really a file. So I'm going to get rid of this all the way. Slight delay, file not found. I'm going to clear the screen. I'm going to say dir, and you'll see something a little bit different now. Okay, so you'll see it's Meatloaf archive as before. URL is c64.meatloaf.cc, and the path is now Foenix. And now you see 3 files here. And those of you familiar with or that have been on the Foenix Discord may recognize some of these. There's something here called Spread It Jr. I'm going to load that while I'm talking. It's capital Spread It Jr.bas. Okay. It'll take quite a while to load, so I'm going to talk and explain to non-Foenix people, there may be some Commodore people watching this, that the Foenix doesn't have a prompt that says loading. And it doesn't have a prompt that says ready with a flashing cursor. It simply takes the cursor away from you. It's still blinking, but if I type, I get nothing. I happen to know it's loading. When it's done, it will say complete. So that's just a quick note for non-Foenix people. For Foenix people, this is loading the file from a share on Jaime's Meatloaf website into my machine through this IEC port and into memory. So in just a moment, it'll say complete, and I'll be able to list the program. This is Ernesto's program. I'll be able to run the program if I want to. I can, given the right kind of utility, I can copy it from that location on the internet into my local SD card if I wanted to. If I have a file manager, for instance, and I believe there's a copy command inside of Foenix DOS as well. So I'm going to list this briefly or quickly. Break it. So now you can see this is the sprite editor code. It's rather lengthy. If I run it, just to prove that it runs. There we go. Ernesto's editor. Pretty handy. Now I'm going to break this with a Control C. At the top you see break in line 10340. I'm going to clear the screen. You didn't see much go away. I'm going to turn sprites off. Okay, I'm going to turn bitmap off, and I'm going to turn cursor on. Okay, get some sanity back. Okay, fair enough. So far I've loaded a program from Meatloaf device, from the internet, that was a basic program. I'm now going to say dir to get back to see where's this disk at the moment. Well, it's in the same place. Now I'm going to load a file the second way. I'm going to load with, let's see what I'm going to do here. I'm not going to load it here. What I'm going to do instead is I'm going to go from this kind of navigating to the Meatloaf device, to the Foenix subdirectory, to a different place on the internet, which happens to be the Foenix Marketplace App Store. And that's where I list all my newsletters and binaries sometimes and programming examples sometimes. And to get there, you use something called a short code. You still use the load command. And what you do is you type ML:, the name of the short code, Foenix in this case. Press enter. Oh, it's complaining, or it's giving me the chance to save my work. I want to continue. Yes, I'm not going to save my work. Okay, file not found. There's that brief delay and then file not found. Of course, that file not found has to be suppressed. Something we'll need to do in microkernel or in SuperBASIC in the kind of a future version to be aware of this. Now I'm going to do a directory from here. And you'll see something quite a bit different. At this point, my Meatloaf archive is on a URL called apps.emwhite.org. The path is Meatloaf, and I've got 4 folders here. One called apps, demos, games, and utils. All right, now I'm going to go into, let's see, I'm going to go into utils. I'm tempted to type CD, and that's not the right way to do it. You always have to do a load. So now I've loaded it. I'm going to do directory. Okay, you'll see 3 files here. I'll put on the screen here, the kind of as I'm changing directories, what the tree looks like. But I'm going to do a bload command from SuperBASIC. I'm going to load Saki 2000.bin quote. Okay, the bload command is a binary load command similar to what the Apple did, the Apple II. And the syntax is you say bload file name, comma, address in hexadecimal, and this is a 2000. Okay, now I need to tell Commodore people here that the Foenix machine does not have a standard where the first 2 bytes of every file are the load address. And for Foenix people, Commodore Basic programs have 0801 or 0108. Is that right? Yeah, 0108, low byte, high byte, as the first 2 characters of basic programs. And then they have the load address of other programs. So here, the first 2 bytes of the file, if it was a Commodore file, would be 0020. But instead, it starts with the first byte of the file, which is probably A9 hexadecimal, which is a load LDA, probably. So I need to tell it exactly where I want to load it. So I'm using bload to load this into memory. This could be a binary program. It could be a bunch of sprites. Could be a text file. Could be anything. I'm going to press enter. It's loading it up. Now I press spacebar. Nothing's going to happen there. It's finally done. It does not say complete with a bload. Now I'm going to say call $2000. Call is the equivalent of typing sys in a Commodore machine. And now this program is running. So I loaded this program from the Foenix App Store over the internet into my machine with a bload command into memory directly. Again, no special software, no special FPGA code, no special version of microkernel, no special version of BASIC. So far I've exercised the basic load command and the basic bload command, and it just happens to work. It's genius, if I don't say so. Typing some commands here, some characters. I'm going to type some meta keys to see that all works. Yep, everything works as I expected. I'll press return to exit the program. Now I'm back there. You see my cursor on the bottom of the screen. Okay, let's see. Shifting gears. I'm going to turn this off. Turn it back on again. Let's come back to SuperBASIC. I'm going to boot up at the normal expected screen. I'm going to say drive 1. I'm going to say directory. And notice something either peculiar, interesting, or expected. And that's that I am still, my context or my virtual drive is still on the internet, on the apps.emwhite.org website. And I still see the 3 files I saw previously. So I want to go up a directory, and how do you do that? There's no CD command, and the answer is on a Commodore machine. Do I have one around here? It's in the other room. I'll put a picture of it on the screen. On a Commodore machine is a key right here where this junior key is, and it's a back, actually it's right here. It's a back arrow. On Meatloaf Commodore, you press this to go back a subdirectory or up a subdirectory. From an ASCII translation perspective, the underscore is also mapped in the same way. So I'll load quote underscore quote, it'll say nothing, file not found, and then I'll get my prompt back, directory, I'm back to my 4 folders. Now I'll say load to, let's see, demos, that's a good one, demos. Okay, now I'll get a directory here. Okay, now I'm in the demos folder. There's a single file in this one called balls, balls.pgz. What's a PGZ? For Commodore people, PGZ is kind of like a PRG program that auto loads into a specific address, and embedded inside this file is not just the low byte, high byte of the load address, but also a multi-segment format where you can put different pieces of code into different areas of memory, all over memory, and execute it. So it's kind of like a Commodore load address on steroids. There's also a PGX. There's a PGX format as well, which also has the load address, the execution address, and a single segment of code in it. But to load it, you need to do something special, and you can't do it from SuperBASIC. Again, this is just generic F256 stuff, but I'm going to type / space and the name of this file to load it. One exception though, the fact that I said drive 1 isn't really helpful. I need to explicitly say 1 colon to indicate I'm taking it from this Meatloaf device. I'm going to say balls.pgz, and you're going to see 2 things happen. Screen's going to clear. It's going to say pexec, and then it's going to say what pexec does. Well, it can load various programs. Cool. And then you'll see a number of dots populating the screen left to right. Each one represents, I think, 128 characters, 128 bytes being loaded across the device. At the bottom of the screen, you'll see the stick figure person trying to run across the screen very slowly. Of course, if you were loading it locally from a drive, it would go pretty quickly. But just to give you an idea of what you're looking at here. And then this program will load. This is a rather small program. It's less than 2K, 7 blocks. 7 blocks of what? Each block is about 255, 256, 254 characters, depending on what device it's coming from. I'll press enter here and we'll get on with it. It's loading it. There's the dude. There's the dots. There's the application. It's running. So this is, who made this? I'm going to say Kelton Soren, S-O-R-E-N, I think is his name. I think he's from Sweden. I could be wrong there, and I'm probably mispronouncing his name, but he created this. I'll put a link to the GitHub. It's a multiplex sprite demo that has, I don't know, 192 sprites or something on the screen at once. It's pretty amazing considering the machine only has 64 sprites. So that's what this is all about. Okay, I'm going to reset my machine now. So far I have demonstrated load, bload, and pexec. There's another thing I can do. If I say /DOS, actually, let me see where I am first. I'll do it from inside. Am I going to do it from inside? Yeah, that's fine. I'll do it from inside DOS. Okay, I'll say 1 colon. I'm going to say help, and I'm going to use one of these commands. I don't know. Let's do a dump of 1 colon balls dot, probably S, PGZ. Dump is a command written in machine language as part of the F256 DOS shell. And what it does is it reads a byte from the disk and it puts the hexadecimal value on the screen. It's formatted in probably, I don't know, 16 bytes wide or something like that, maybe 32 bytes wide, kind of like a machine language monitor. So without worrying about load, bload, pexec, any program written using the microkernel with normal calls to open a file, to read a block from a file, works with this device. Nothing needed, nothing extra, no worries. So here's the balls program we just ran in hexadecimal format from beginning to end. So that's pretty cool. But wait, there's more. The best thing that I know, the best thing I've seen yet with regard to this, besides everything, and I'm not even going to talk today about the fact that you can run across different sockets, or services, I should say, that you can use kind of a WebDAV file share format that you can print through this thing online into a PDF file that gets delivered to you on your PC or Mac or Linux. I'm also not going to talk about the fact that you can, well, there's just so much it can do. It can do JSON processing. You can use endpoints on the internet with REST calls to pull data back to your system. It's endless. Despite all that, the coolest thing that this thing can do is to use something called Send to Meatloaf. Send to Meatloaf is something that leverages a plugin from the Chrome App Store that you can plug into your Chrome browser, I assume, on Mac, PC, and Linux. Of course, I'm using Mac here. And what it does is once installed, you can literally right-click on any file on the internet, say send to Meatloaf, go back to your Meatloaf device, and type load. Let me go to basic. Let me go to drive 1. I'm going to demonstrate this right now. See if I can get this going quickly enough without screwing up my video. Rather unlikely, but let's see. Okay, here's this. Here's this. It's my new server. My new. All right, let's see if this is in frame. It's kind of in frame. Yeah, it's upside down. I'll flip it around. Okay, I'm going to go to /apps Foenix Marketplace. Some of you have seen this before. A couple things here. One of which is new. As of December, we have Meatloaf inside. Click what's new to read about this integration. You click here and you can see that. Or you could simply come down to a file. Am I still in view? Yeah, how about this one? The classic snake game for the F256 Jr. I'm going to right click on this. I'm going to move to the send to Meatloaf. Click on it and you'll see something magical. Two things magical. First thing is this pop-up that says, hey, you just sent to Meatloaf. It queued it up. There's the file name, the complete path. Go to your C64 and load it with ML:*8. Of course, we don't have a 64, so I'm out of luck. I'm not out of luck because I have an F256 that it also works via. So I will type load, quote, ML:*, quote, hold on. I can't load it because it's not a binary program. I can go /dash space 1 colon ML colon star. Oh, I made some changes. Do I want to save? Oh, I'm going to continue. Yes, I do. Here we go. It's loading up as before. This is a much longer program, by the way. This is one of the applications that was put together for the October Game Jam, written by a person called Silk Neon, and there it is. So this game is pretty incredible. I mean, I went to my app store and I right-clicked with the Chrome plugin plugged in. I said send to Meatloaf. It said it's there. I went to my machine. I typed in load ML:* through wget. It may as well have been a basic program with a regular load. It could have been a binary program with a B load, and I can just start my game and play. Hope you enjoyed the demo. I'm not very good at this game. See, I lost already. Hope you enjoyed the demo. There's a lot more to talk about here, but oh man, with any luck, the quick overview really whet your appetite. These things will be for sale shortly. I believe Jaime is going to be building a bunch of them, I think 20, and selling these in a nice, attractive 3D printed case for a modest sum of money, guaranteed to work, flash with the latest code. You can have it be device 8, you can have it be device 9, you can build it on your own, you can download this stuff. Next steps for you, if I were you, is to watch the deadline video at the kind of first link in my description of this YouTube video. Think about buying one of these for yourself from AliExpress or one of these places. Buy the cable, cut the cable, do the soldering, flash the code, and get online. I mean, this is a wonderful thing. I'm making a vow to the community. I'm going to continue to curate this kind of folder system with applications that work for the F256 to kind of build that up. But in any case, you can go to any file, like Zimmers, for instance, and download a text file into the more or less editor. Okay, just a quick, because I mentioned it, a quick example of how to load a file from someplace else on the internet. I've got a still shot here of my looking at a file, text file from Zimmers. This is from the Commodore PET directory, and I'm going to simply go into DOS. I'm going to say I'm going to say dump. No, I want to say, what is it, for crying out loud? Some point I'll get it right. Here we are. I'm going to say read 1 colon ML colon star. Here we go. Commodore PET, frequently asked questions. So here you are. I'm streaming a file from Zimmers, because I did right-click send to Meatloaf, onto the screen here. I'm doing this for Micah, by the way, because I know he's likes to keep on track with all of the developments in the pet community. That's all I have for today. Hopefully you liked it. There's a lot of follow-ups, a lot of things you can do. But you should start, as I mentioned before, by building your own. And by the time you get it and build it, there'll be so many files on the Foenix App Store that you can download through this, what I'll call curated content folder. It's going to make your life a lot easier. And you know what? Yeah, IEC is slow, but I think it's worth the wait. You know, we're in the habit of pulling out your phone and getting things like really quick, like online, instant access and that kind of business. Listen, these machines were old. When we were young, it was good enough. So find something else to do with your spare time while you're loading up a file that might be, you know, 30, 40K in size. The fact that this works at all is really a small miracle. So I want to thank, as always, Jaime for his help. I met Jaime around 2 years ago. We had some, you know, false starts trying to get this thing to work for the Foenix. And he approached me around, I don't know, 2 or 3 weeks ago and said, hey, Mike, try it again. Sure enough, it worked. And the deeper I get into this, the more impressed I am by it. So thank you again. Look for us at the VCF East. I'll have a table there in 2025. I'll also be presenting in a time slot that I think is 10 a.m. on Saturday morning. It's music related, and I'll have my Moog modular system there in addition to some other type of synth action. That's all for now. Apologies for the, 40 or 50 minute video. Hopefully you found this part interesting, it was worth your while, and we will catch you soon.